Example, if we have again host 1 ESXi and ESX2, for sure they are both on the same transport zone. And then we have here our VDS is spanned across these ESXi's, and then we have here our VMs. Let's say that these ESXi's on the same network or whatever, or on two separate networks. So for example, we have here, it doesn't matter. So we have here 192.168.0.1 and here 0.2. So in order for this overlay network to work, overlay here is explained. So in order for this overlay to work well, we create something here is like a layer 3 software port, a layer 3 software port, and here a layer 3 software port. Okay, and this maps to a port on the VDS and a port on the physical ESX. Here also it maps to physical port on the distributed virtual switch, and then on physical NIC on the ESXi. And sure, we have here our physical network. Okay, so now these ESXi's are ready to talk across overlay networks. And in this case, the overlay networks here will need a virtual network identifiers like VLANs, like what you know in VLANs, but these VNIs will be started to be tagged from the number 5000 in order not to be contradicting with the existing VLANs. These networks actually is called the Genève networks, and you can create, for example, up to 4096 squared virtual network identifiers. Okay, so numbering these overlay networks from 5000 or 5002 is giving us information that we are dealing with overlay networks. Okay, so if we are going to create a network here, an overlay network here, which is the VNI for it is, for example, is 5002. This is the VNI of this overlay network, and this VM, for example, which had the IP of 10.0.0.1, needs to send packets to the other VM here on this ESXi host, which is its IP is 10.0.0.2. So the traffic actually will go from here, from VM1 here in the VM kernel port here, because this port is actually a VM kernel port, is a layer 3 port, which is actually is the TEP port, which is doing the tunneling here, and then to the VDS, and then on the virtual network from the ESXi1 to the physical network here, and then goes to, then this is actually is done through a Genève header here, a Genève header here, because this layer 2 traffic is encapsulated on the Genève frame to be sent to that ESX and then to the other layer 3 port here, and then to send the traffic to finally to VM2 here. These ESXIs for sure report the MAC addresses and the routing tables to the NSX manager, and then NSX manager is updating all the ESXs in the environment. This is actually what is called the logical switching, which is layer 2 over layer 3. And remember, the same will happen if these VMs are on two separate networks. And that's the beauty of NSX. Another important note here is that NSX network equipments here need to support jumbo frames. So we do a change on the routers to extend the MTU to be supporting 9000 in size. So again, MTU size has to be, I'm sorry, let's erase it and write it again. MTU size on network equipments has to be 9000. And this is a fact because of the encapsulation needs the packet to be longer in size. So remember, what we need to say here and clarify it more is that these VMs on the same overlay network, which is 5002, the virtual network identifier of it, but it doesn't matter if these ESXIs on the same network or not, in order to clarify it well. Okay, so now this is logical switching. So what if we need to know about logical routing? So we are going to draw again the ESX1 and ESX2. Okay, and the distributed virtual switch here, and then we have one VM which is its IP is 10.0.0.1, but the other VM, which is VM2, is on another subnet, which is 10.0.1.1. Okay, and we have here two separate overlay networks. Let's say that these VMs belong to this VM1, belong to this network, and this VM2 belongs to this network. The identifiers for the overlay is, VNI here is 5000 to 5004, for example. So what we need to have traffic go from VM1 to VM2, we will need a tier 1 gateway here, and this tier 1 will be connected to this network and to this network. So the traffic will be going from this VM like this to the tier 1 and then to the other network and then to the other VM. And for sure we have here a service for the T1 that is spanned across the ESXis here, this service from the tier 1 gateway, which is the default gateway service. Also the routing tables are here, and the routing tables are here too. But remember, one important thing is that physically we had these layer 3 or VM kernel ports, which is step ports, so we are going for sure to use them for communication. So this logical traffic that I draw in blue exactly is going to go this way to the ESX here, and then go this way, and then go back to the VM through the VM kernel layer 3 ports. Another thing to remember is that if we have our NSX manager is going down, for example, NSX manager is going down for some reason, then we will have all of these things will be working fine, no problem, until we get the NSX manager back again in order to do something new or something. But if it's down, all these things will be working normally. One exception to that traffic, remember this, one exception to that traffic we draw here, if that or if these VMs are on the same host, we will not need to go through the layer 3 ports or VM kernel ports. And remember, there is no problem if this tier 1 is on the other ESXi, for example, which both VMs resides, because as we said before, distributed gateway is, or this service of tier 1 is spread across the cluster. Okay, so now we're done, and we need to remember only that this traffic is on overlay network, and only the VLAN transport network, which is on VLAN transport zone, is only for uplinks or edges, not the communication between VMs. At the end of the video, I'd like to thank you for viewing, and I hope this has been informative for you. Thank you very much.